All right, so here we go. I know we just did something with absolute value, but I wanted to go over just a few more things and show you some examples so you can look at them. This will help you guide it. It will give you guidance as you work on more of these problems, okay? So remember, we just talked about absolute value is the distance a number is from 0 on the number line, okay? So if we even saw a number line, right? So absolute value of x equals 4 is actually saying that, okay, 4 is 4 away from 0. So x could be 4 here. Or negative 4 is 4 away from 0. A distance is always positive. You can also write this, if you don't want to do all that, you can do plus minus 4. This is saying positive 4 and negative 4 are both solutions. Now, if we get to one like example 2, here's the trick. The trick now is absolute value of x plus 3, or 2, equals 3. So we could say that x plus 2 could equal 3, or x plus 2 could equal negative 3. Okay? So x plus 2 could equal 3 or negative 3. So then I solve each of these little miniature equations. So x equals 1 or x equal negative 5. Those are my solutions. X equals 1 or x equal negative 5. Now, if you want to test them, you put them back in. Because we'll actually have to do this for what's called extraneous solutions in a minute. Like you can see the phrase down there. So if I put 1 back into this, I substitute back in. The question is, if I put 1 back in, do I get 3? Well, 1 plus 2 is 3. And the distance 3 is from 0 is 3. So 3 equals 3. We're good. If I put negative 5 in, absolute value of negative 5 plus 2 equal 3. So absolute value of negative 3 equals 3. So 3 equals 3. We are still good. So both of these solutions check out their answers. Okay? All right. So what about the next one? Okay, so we have absolute value of x minus 7 equal 4. So x minus 7 could equal 4. Or x minus 7 could equal negative 4. And then I solve. So plus 7 plus 7, x could end up being 11. Or use calculator if you're not sure about these numbers, x could be 3. So 11 or 3. Now again, I can test them. Absolute value 11 minus 7, is that equal to 4? Well, absolute value of 4 is equal to 4. Yes, that's good. If I put 3 in, absolute value 3 minus 7 equal 4. Absolute value of negative 4 is 4. That is true. So these two are correct. Okay? All right. Now, again, if you missed class for some reason, then you didn't see the slides we did. But if you did, then we walked through that. Now let's say we have a problem like number 1. And number 1, you've got this plus 7. Now this is where we go back to our order of operations, right? You've got grouping, exponent, multiply, divide, add, subtract. We have to reverse this order. Well, this is the 2x minus 1 is all grouped inside of the absolute value sign. What isn't is plus 7. So I have to first get rid of everything outside of the absolute value sign. So I now have absolute value of 2x minus 1 equals 7. So, just like the one above, everything inside the absolute value sign, the whole thing could equal 7, or 2x minus 1 could equal negative 7. Now, let me go ahead and give you a warning here, by the way. A lot of people are only going to do the one. You're going to go, I got the one, but not the other. You have to take into account that thinking of the number line, that it could be the same distance from 0 one way or the other, or the same distance from really the middle number. We start off at 0, but as things shift, it's the same distance from one middle number to the other. So plus 1, 2x equal 8, and divide by 2. So x equals 4. Or plus 1, 2x equal negative 6. x equal negative 3. So x equals 4, or x equals negative 3. Now let's test them. If I put 4 back in, I'm going to put that over here. So absolute value, 2 times 4 minus 1 plus 7 should equal 14. 2 times 4 is 8, minus 1 is 7. Absolute value of 7 plus 7 equal 14. Absolute value of 7 is 7. 7 plus 7 is 14. Check. If I put negative 3 in, absolute value 2 times negative 3 minus 1 plus 7 should equal 14. Well, that's absolute value of negative 6 minus 1. That's going to be negative 7, but the absolute value of negative 7 is 7. So 7 plus 7 equal 14. That's right. Okay? All right, so this is our check. Okay? All right, number 2. Again, I'm going to do this a different color. Again, we have this problem where you have to get rid of some stuff. Okay? We've got the absolute value. We have to get it alone because it's in a grouping symbol. So we have to get rid of everything not in the grouping symbol. So plus 1, negative 2, absolute value of x plus 3 equal 6, divide by negative 2. So the absolute value of x plus 3 equal negative 3. Now, here you go, guys. Think about this one. In this problem, you have the absolute value of something. Everything else is gone, equaling a negative. Now, it's got to be all by itself. In that case, I can't have something absolute value come out and be negative. Yes, there could be a negative in front or something that could do that, but that's why we get it alone. That's why we get it by itself. So this is actually no solution. So we don't even have to do it. Or we don't have to go any farther. Okay? All right. Number 3. So again, we have to get this alone. So plus 6, plus 6. Now this one is kind of the reverse of the previous, and here's what I mean. Yes, we have negative 8, but when we divide by negative 2, we get the absolute value of 7 minus 3y equal 4. Because we have to get rid of everything not inside the absolute value symbol before we can start to work this out. Okay, so here we go. We can say 7 minus 3y could equal 4, or 7 minus 3y could equal negative 4. Now, once we do this piece, I don't care about the negatives. Like, we just have to, in order to deal with the absolute value, this can't be a negative number. So minus 7, negative 3y equal negative 3. And by negative 3. So y equals 1. Or minus 7, negative 3y equal negative 11. Y equals 11 thirds. These are two possible solutions. Now, we do need to test them for extraneous solutions, okay? So when I say that, when I say test for extraneous solutions, I'm going to put over here test. I'm not going to do this for all of them, but I want you to see this. When I test, I put my answers back into the original. So negative 2, absolute value, 7 minus 3 times 1 minus 6 should equal negative 14. Well, let's see. Negative 2, that's going to be 4 minus 6 equal negative 14. It's going to be negative 8 minus 6. That's going to be negative 14. Check. If I put 11 thirds in, negative 2, 7 minus 3 times 11 thirds minus 6 equal negative 14. Okay? Well, if I negative 2, 3 times negative 11 thirds is negative 11. So 7 minus 11 is negative 4. But the absolute value of negative 4 is 4. So negative 2 times 4 minus 6 would be negative 14. So both of them work. So there are no extraneous solutions. Extraneous solutions mean solutions that look like they work but don't. Okay? All right, this one. Now this one's okay. I'm going to do this one algebraically. I will also show you in Desmos. So x plus 6 is all by its lonesome. So I can say x plus 6 equal 2x. Or x plus 6 could equal negative 2x. You're like, what is the variable? It's the same concept. It could be the positive or the negative, and it would work. Once I do this, I solve. Now, if you don't remember, I need to get variables. When I've got variables on both sides, so they're the same variable. If it's one variable, you've got to get them over to the other side. So 6 equals, don't forget there's one of these, 6 equals x. So x equals 6. Okay, okay, subtract x. 6 equals negative 3x. So x is negative 2. So there's your answers. Now, you got to test them. So if I put 6 in, 6 plus 6. Okay, here's one that doesn't work. 6 plus 6. Oh, yeah, it does. 6 plus 6 is 12, absolute value of 12. So if I put that in over here, 6 plus 6 equals 2 times 6. Well, yeah, 12 equals 12. Thank you. And then if I put negative 2 in, let's try it. Negative 2 plus 6 equals 2 times negative 2. Now watch what happens. This ends up being 4, but this ends up being negative 4. That's not true. So negative 2 is not an acceptable solution for this. So all we have is x equals 6. Okay? Now, the way that you would do that in Desmos is as follows. Give me a second to get out of here so I can show you. In Desmos, I can do this with any of these, by the way, but I can say y equals, okay, oh, got that in caps, y equals, sorry, lost my equation, one thing. I'm trying to find it on my other computer. There we go. Y equals absolute value x plus 6. So I'm going to put my keyboard on. Um, absolute value x, whoops, plus 6. So there's that graph, right? And then I'm going to put the other side, y equals 2x. There you go. Now look, when we zoom in, remember we said only one solution works. Well, there it is, 6. Okay, remember negative 2 didn't work. So negative 2 is over here somewhere. Because look, negative 2, the reason it kind of happens, if you look at it, is what you've got is, well, no, that wouldn't be a good explanation. So negative 2 did not work, but 6 did. So you can always test these, by the way. You could pick another one. If we took number 1 that you did, so we had 2x minus 1 plus 7. And then we had 14 here. Look, negative 3 and 4. Those were our two solutions. Okay? So that's another way to do these. Now, algebraically, you should be able to do this, especially my honor students. But if not, then you can do it this way. Okay? So I'm going to do number 5 this way. Number 5, absolute value of x plus 1 equal to x. So I'm going to write this. I'm going to write this as two functions. A system of equations is what it's called. A system. It's called a system because there's more than one. There's a bunch of them. So y equals, I put this side as y equals, and then y equals 2x. If I put these two equations into the calculator, I should get a graph that works. Let's try it. Let's see. Absolute value of x plus 1 plus 1 and then absolute value of 2x. There you go. So 2 is my solution. 2 is my solution. All right. Oh, I keep opening that. Sorry, y'all. So over here, I would just put x equal 2. Okay. Now I'm not going to do all these. I will tell you that one like this. Number 6. Sorry, I had to truncate there. Had to cut it off. When you've got two absolute values, you can actually treat it as just like this. X plus 5 equal to the positive of this, or x plus 5 equal to the negative of all of this. Now, again, you could do this in the calculator. If you're like Duncan, Mr. Duncan, I don't get that. You can use y equals, and find your answer. And I'll show you that to you in a minute. But right here, if I solve this one, I need to get my variables all to one side. So 5 equals x minus 1 and add 1. So x could be 6. That's one answer. Or, okay, this is tricky. Follow me. You distribute the negative, you get negative 2x plus 1. You distribute that negative, like a negative 1 almost. So it changes everything's sign. Now if I subtract x, minus 1, I get 4 equals negative 3x, and divide by negative 3. So I get x equals negative 4/3. So these are my two answers. Or, okay, now let's look at this in Desmos. So in Desmos, these are my two equations. Notice that I have 6, which we said. I've got negative 1.33. Well, if you type negative 4 divided by 3, you get negative 1.33. So there you go. Okay. Now, for the rest, you can stop now if you'd like. I will show you how to do these, especially for my honor students, actually. For my honor students, push through. If you're a regular math 3 and you want to see, here it is. So I would still set 7 up. The trick is the answer for 7. So I'm going to do something a little funky, but it will help you for later, by the way. So x squared minus 3x equals 4x minus 12. That's not all that funky. Or x squared minus 3x equal the negative of this, 4x minus 12. Okay? So if I solve this one, here's the deal. This is a quadratic. This will show up in our next unit. So this is kind of intro to next unit. I'm going to subtract 4x. Okay? So I get x squared minus 7x equal negative 12. Add 12. So x squared minus 7x plus 12 equals 0. Okay, hold that thought. We will solve that. We'll come back. Let's do this one. X squared minus 3x equal, you distribute like you had a negative 1 there, because that's really what you have. You're saying, I want the opposite of all this. So negative 4x plus 12. Okay, I bring it all over. So plus 4x plus 4x with a quadratic. If you want to solve for x, you've got to bring everything over to one side. Minus 12, minus 12. I've got x squared plus x minus 12 equals 0. Okay? So that hasn't gotten us any closer to x, right? Well, sort of. Okay? All right. So some of you are going to be freaked out by this, but stick with me if you want to know it. We can factor this. So this first one, I'm going to put it in this box right here. So the first one I'm going to put in this box right here. So I can factor this. I'm going to zoom in a little bit. Okay? I have to find factors of 12 that factor to give me negative 7. And here's what I mean. Negative 3 times negative 4. Negative 3 times negative 4 gives me 12. But negative 3 plus negative 4 gives me negative 7. So this can be written as the factors x minus 3 times x minus 4. Now I'm dropping a lot on you right now. We'll cover this more later. But some of you can handle this, and you'll be okay right now. But here's the deal. When I factor something, I'm saying this times this gives me that last number. X minus 3 times x minus 4 equals 0. Well, in order for something times something to equal 0, one of them has to be 0. So you can say x minus 3 could equal 0, or x minus 4 could equal 0, and solve. So x could be 3, or x could equal 4. Okay. Now, we haven't even gotten into if you plug them back in, will you get that? If you plug them back into the original. But we'll hold off on that. So there's two possible answers, 3, 4. Okay. Let's slide over here. Same exact concept. So right here. Okay, so factors of negative 12 that add to give me 1. Well, that could be 4 and negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is 1. So this could be broken up into x plus 4 times x minus 3. If you're sticking with me and you're not honors, I'm proud of you. This is hard to do. Well, this times this equals 0. So I can say x plus 4 equals 0, or x minus 3 equals 0. And we solve. Minus 4, minus 4. So x could equal negative 4, or plus 3, x could equal 3. Now here's your deal. So what you've got, notice 3 is in both of these. 3, 4, and negative 3 are all choices. The question is if both of those actually work. We'll check in Desmos, and then we'll talk about how we know. So I'm gonna put this, both sides of this, the original, the crazy equation. So I'm gonna put that as y equals, and I'm gonna put this as y equals, and let's see. Now here's why. It could still be 3 solutions. It could. So let's look. Let's look. So absolute value x squared minus 3x. Oops. Absolute value x squared minus 3x. So y equals absolute value x squared minus 3x. All right, okay, see that little bounce? That's kind of cool looking. Look at it. See? That's because of the absolute value. It can't go below 0. So it's like the quadratic all of a sudden tries to go down and it can't. It can't cross the x-axis. Okay? The other equation, if I can't remember, is 4x minus 12. I did it again, y'all. Okay. Mr. Duncan, come on. 4x minus 12. So let's graph that. 4x minus 12. All right, so here are my two solutions, 3 and 4. So negative 3 is a extraneous solution. Now check something out. I want us to try something. Let's say you didn't have that. No, it still wouldn't work. Okay, I wanted to see something. All right, so when we look at this, our answers, so we can always check our answers for extraneous solutions in the calculator. So our answers are 3 and 4. Okay, negative 4 did not work. So the answer to this problem, this crazy problem, is x equal 3 or x equal 4. Okay, all right. So that's kind of insane. So that's what we did today. Let me shrink it down. That's all of that. Okay. All right, I'm done. I'll have you practice some of these, and we'll go from there. All right, have a good day.